Hey everyone, good morning, good afternoon, good evening, wherever you're joining us from. We are doing this in an APAC friendly time zone. So, if you're joining us from Singapore, Australia, New Zealand, Malaysia, hey everyone from India, you can use the chat to let me know where all you're joining me from today. My name is Aditya. I work as a developer advocate with Salesforce, and if you have seen me previously on YouTube or LinkedIn, you know I work a lot on these videos, blog posts, and any technical content that I can enable you with. I work on that. And before we get started, I'll give people some time to join. And in the meanwhile, I'll keep looking at the comments. I know that there is going to be like a 20-second lag between the stream and what I'm saying. So I'll be mindful of that when I'm looking at the chat comments as well. So, hey Megesh, I'm doing well. Hey Shantanu, hey Munawar, Rishabh, hey Rick, hey Amrit, hey Venkata, hey Nagaraju. Anybody from outside India? Anybody from Singapore, Australia, New Zealand, Malaysia, Philippines? So if not, I would encourage all of you to share this link with them and encourage them to join. So these live streams keep happening every week. We come up with new topics. So today we are going to talk about Apex cursors. Last week we had a topic on model API, and before that we had something on data cloud. So we keep mixing the topics up. It's either going to be AI, data, or platform-based topics. So today in this stream, like I said, we are going to be talking about Apex cursors, and a disclaimer here that this is a feature that is currently in beta, which means all of you can try it out, but then the features, the limits, etc., are subject to change by the time this goes GA. So without any further delay, let me jump in right to the topic. So I see a few people from Bangladesh. Eric is from France. Thank you for joining us. How early is it in France? I'm sure it's quite early, but so thank you for joining. Hey Jan from Sydney. Um, Thanks, Shantanu. So let's move on to the next slide, which is the most important slide. Like I said, this feature is in beta. So please make all your purchasing decisions based on generally available information. This Apex Curses is not for purchase. So please use it in production based on generally available information and not based on what I show you today. So first of all, what are Apex cursors? So Apex cursors is a new feature that lets you process large amounts of results from a SOQL query within customizable batches. So I want all of you to put in the comments what are the general scenarios where you use things like batch Apex in order to process large amounts of data, and what are the limitations that you typically run into when working with these large sets of data, because Apex cursors attempts to solve some of those problems, if not all. So we will discuss in this stream, we will see what Apex cursors is all about, and we will talk about different scenarios, and then we will keep it like a free-flowing discussion. All right. So basically, like I mentioned, you have a large set of data that is returned by a SOQL query. And if you want to process that in chunks, that is where Apex cursors is going to be helpful. Now, that is something that you can already do with batch Apex today, but then Apex cursors gives you a little bit of more flexibility than batch Apex, and we are going to see what that is. So typically in a batch Apex, if you want to like write a query that gets large amount of records, you write database.queryLocator, and that's something that is present in your start method. And batches of those, depending on the batch size that you configure, will be sent to your execute method. So that's how it works in a batch scenario. But let's take Apex cursors as an example here. How does the syntax look like? So we are going to be using a new method called database.getCursor. So instead of writing database.getQueryLocator or database.query, we are going to be using database.getCursor. And you're going to specify whatever query it is that you want. as a parameter. Now, what that is going to return, it's going to return a cursor locator, which is going to be stored in your locator property over here, which is of type database.cursor. So pretty simple syntax. You'll just initialize a cursor with the query that you want. Now, what happens if once you have the locator, you can now start getting in small batches of data from that particular cursor. So the syntax for that is going to be locator.fetch, and then it's going to take in two parameters. First is the start position, and the second one is the number of records. So if I want to fetch the first 200 records from the cursor, I'm going to use locator.fetch. Now, the important thing to remember here is when you use database.getCursor, it is not actually querying your data. So it's not returning any result set. It's only returning a pointer to the result set. When you do locator.fetch, that is when the results are being returned depending on the start position and number of records that you specify. So here I'm returning the first 200 records and I'm assigning those 200 records to a variable. Now I can keep repeating this. So let's say in my transaction, I have another requirement where I want to fetch the records starting from position 800 and I want to fetch 120 records. Now this is a very hypothetical situation. So basically what I'm trying to show you here is you have complete control on from which position you want to fetch and how many records do you want to fetch. And the advantage that you get with cursors. So if you take batch apex, if you're trying to compare this with batch apex, now if you're trying to iterate over the results that you're getting, you're able to only move in the forward direction. So let's say you define your batch scope as 2000 and you have a million records. So then you get a sequential batch of 2000 records each. But cursors, it gives you the flexibility to go back and forth. So it's not a sequential order that you want to get the data from. So for example, in the same transaction, so let's say I'm fetching 0 to 200, and then I'm straight away jumping to 800. What I can do is I can come back and fetch the records from position 20 and get 10 records. So it's like a cursor that is always there with me with complete flexibility on what records I want to retrieve, depending on the business scenario that I have. So that's what cursors does. Now, while all of this looks simple, there are a few limits that are associated with this, and there are a few key considerations that we need to remember. Again, this is currently in beta, so things might change by the time it becomes generally available. So I'm going to talk to you about whatever is there right now. So right now, basically, whatever cursor that you're creating, that is fully serializable. So if you remember from the earlier slide, so we have defined the cursor, and then within the transaction, we are trying to fetch different number of records from that particular cursor. So for each transaction, you need not create a new cursor. So a cursor can be reused between different transactions. The reason for that is this cursor is fully serializable, which means you can convert it to a string. Essentially, that's what serializable is, and store it somewhere. And you can retrieve that cursor back, whether it is a database, custom setting, or wherever that is. You're going to retrieve that and reuse it across different transactions. Now, that is again a second advantage you're going to get. You have a cursor defined, use it between multiple transactions. You need not create multiple cursors. And this cursor and the result set that the cursor returns is valid for 2 days. So let's say I have written a query, select ID from contact, and it returns 200 results. For example, ideally it can return up to 10 million records. We will talk about that later. But let's say it returns a particular result set. So your cursor is going to have an ID, and with that ID, these results are going to be mapped. So this set is going to be valid for 2 days. So each time you use a cursor ID, you will have access to that set of 200 records or 10 million records, whatever that is. So that's the concept of a cursor and the validity of the result set that is generated from the cursor. Now, what are the implications of this? How is this going to look like in a real life scenario is something that we are going to see further in the stream today. So important point, define a cursor, use the fetch method to get records from the cursor, and the cursor can be stored and reused for up to 2 days. Now, what are the limits? Let's talk about a few limits. So first, whenever you define a cursor, the cursor can retrieve a maximum of 50 million records per transaction and 100 million records per day across all the different cursors that you have. So that's something that you need to keep in mind. If you are defining multiple cursors in a particular day, it can only retrieve up to 100 million records, with each cursor returning up to 50 million records. So if you have 50 million records being written by a cursor, then you can create one more cursor which returns only 50 million more and not more than that. So that's the maximum rows. This is a limit as of today. And then how many cursors can you define per day? So now there is an upper limit to that as well. So each time you call database.getCursor, it creates a new cursor for you. And you can only create a maximum of 10,000 new cursors per day. So that's the limit that you're going to have. And we also have a limit of the number of fetch calls that you can have in one transaction. So you can do a maximum of 10 fetch calls per transaction. And of course, like I said, the cursor is reusable across different transactions. So if you're able to split your logic up, you can use many more fetch calls, still bound by the 10 per transaction limit. So that's what cursors gives you. Now, let me see some questions. Okay, so there is a question, so Salesforce real-time scenarios, that's a good channel name. Salesforce real-time scenarios is asking, will it give any error after reaching the limit? Yes, there are exceptions that are thrown if the limits are reached. So this is like a standard Apex feature. So limitations are there and exceptions are thrown. Sorry if I'm not spelling your name right. Mike Hilo says it would be awesome to increase the offset property to be more than 2000 instead. Yes, it would be awesome, but we are going to look at the exact same scenario. How do you get over that offset 2000 limit? By working with Apex cursors instead of writing a SOQL query with the offset property. Yes, Megesh, it is very similar to the offset property. In fact, the scenario that I'm going to show you is exactly going to talk about that. Okay, so let me move on and let's see what we are dealing with. So what are the use cases that typically come into mind when you talk about Apex cursors? For now, it is pagination support. So all of you have the same concern, like there is an offset 2000 limit that can be bypassed using Apex cursors. It comes with its own set of limitations, which I'm going to talk about. The other use case is to obviously process large amounts of data. Instead of using batch, you can go with a queuable job. So within a queuable job, you can get a cursor, break the results up, and chain your queuable jobs to process different segments of results from your cursor. So that's something that you can do. I'm going to show you an example of how it is. Now, the advantage that you get with this when compared to a batch Apex is two things. First, you can go back and forth in the result set. Batch only allows you to go forward, but with Queueable, you can go backwards and forwards. Where you are querying the results, what part of the chunk are you dealing with is totally in your control. The second advantage that you're going to get is customizable scope. Now, you might say, even with batch, I'm able to customize the scope, but once you define the scope for a batch, all the jobs are going to run with the same batch size. But here you get to control, let's say you're chaining different queuable jobs. For each chain, you get to control what the batch size is going to be. So let's say you decide for the first 100 records, there is a lot of data in terms of related lists that these 100 records contain. And you need to process them in minor batches, like batch size of 10. But then as you move on through the chunks, you decide the related data is not so huge. So you can process many more records in a single batch. So that way, whenever you're iterating through these results, you get to control the batch size of every single iteration. Now I'm going to show you that example as well, but these are the two scenarios that Apex cursors will help you with. So that brings us to the end of slides. So let's actually write some code and see how it looks like. So what I have here is a plain old Sales Cloud org, bunch of standard tabs. But what I have created here is a custom component that shows a list of leads with basic pagination. Now, whenever you look at this, if you have created something like this already, you have a fairly good idea about how this code is written. So I have an aura enabled method that gets me the list of leads, which takes in two parameters. One is the start position and the number of records. And of course, there's going to be a query with a limit and an offset. So limit is going to be the number of records I want to return, and offset is going to be the start position. Now with this, all of us know that there is that 2000 offset limit. Now let's see with cursors, how are you able to get out of that? So first of all, let me show you how you write a basic cursor. So you start off by saying database dot, what is the syntax? Database dot cursor. You have a cursor property and you write database dot get cursor method. So instead of using database.query or get query locator, we are going to be using database.getCursor, and let me write my query, which is select ID from lead. Now I can add whatever filter conditions that I want in this. Basically, we are writing a query that gets me the result set that I want, however huge that is, until the limit hits. So this is a developer org. I can't store huge amounts of data in a developer org, so I'm going to get a reasonable amount of records back. So now what you can do, let me debug and show you what the cursor is going to contain. And also we have different methods that basically tell you how many records this cursor is going to retain. So we have a method called get num records. So this is going to tell me how many records are going to be present in the result set returned by the cursor. So if it is 10 million, it's going to say 10 million. In this case, it's not going to be so huge. So I've defined a very simple cursor. I'm trying to debug and show you what the cursor itself contains. And then I'm going to print the number of records that the cursor has. So what I'm also going to do is I'm going to try and retrieve the list of leads from this cursor. So I use cursor dot fetch, and within that I can specify the start position. Let's say I'm trying to get it from the index of 0, and the number of records that I want to return. In this case, let me say it is 200. By the way, the upper cap for this number is 2000. You will be able to fetch 2000 records from a given index position at a given time. So I'm trying to print the lead, so let me only just get 10 records for now. So for get lead L in scope leads, system.debug L.name. Of course, I need to query the name. The same limits apply, by the way. If you're trying to use a field without querying for it, you get exceptions. So let me also make this a little beautiful. Okay, and then here we have num records. So I'm assuming this code is clear. We are basically getting the cursor. We are just printing and seeing how this cursor behaves. So what I'm going to do now is I'm going to execute this as anonymous. And what you see in the logs is it creates a cursor. And you see once I print the cursor, or if I serialize it, this is what it's going to contain. It's going to contain a query ID property, and it's going to contain the ID of the cursor. So this is something that you can store and reuse across different transactions. That's what I was talking about. And if you see the number of records that are retrieved by the cursor, when I say retrieved, it is not coming into my transaction. The cursor is pointing towards a set of 3021 lead records, out of which I'm retrieving 10 records, which are then coming into my transaction. So until I use the dot fetch method, I won't be getting any results into my transaction. The cursor is just pointing to a location. Um, Imagine a hypothetical location where these 3000 records are present. So that's how typically this code behaves. Now, if I want to reuse this particular cursor, I already have pre-written a code for that. In the interest of time, it's going to look something like this. Pretty simple code actually, but I'll explain it to you. So essentially, when you serialize a cursor, this gets converted to a JSON string that you can store. So it's going to look very similar to this. All you need to change is the cursor ID. So let's say I have saved this particular cursor ID somewhere in my database to reuse in the future. I'm able to retrieve that cursor ID using whatever method that is. And you can deserialize it back to the cursor. And then we do the same process. So either you create a cursor or deserialize an existing cursor. Both of these is going to work just the same. Now let's see what happens. So this is a cursor from the previous testing that I have done. So let's see what this does. So when I select this and say execute anonymous with currently selected text, now it's going to run the same code and you have a different cursor returning the same number of results and so on and so forth. So that's how you can reuse a particular cursor across different transactions. And this cursor is going to be valid for a lifetime of 2 days. So that's some basics about the cursor. Now, what we are going to do is let's update this code in order to use a cursor instead of writing a query this way. So very simply, what I can do is let me copy this code and put it here. And all of this query is going to go inside my cursor. So essentially what I'm doing is replacing the static query with a cursor. By the way, you can use your with user mode here so that the results respect the user that is querying the results. And you need not specify any limit or offset. The reason is that the cursor is going to retrieve all of those results, and using the fetch method, you can control both of them. So I specify it this way. And then what I'm going to do is I'm going to return cursor.fetch and start position comma num records. So this query is going to exactly perform the same. I can comment this out or I can remove it altogether, but essentially instead of returning it this way, I create a cursor and return the start position number of records. Using that, I return the records that I want. Now, typically you would think this is how you write this method in order to get the records. But remember about the limits. Now you're dealing with an Aura enabled method that is surfacing results to a Lightning Web Component. Now, each time you refresh the page, you're going to again create a new cursor. Or in this case, the start position and end position. Each time I go to the next page, my method gets invoked, and each time a new cursor is being created, which is not really a best practice because for pagination, you need not always create a new cursor. You can reuse an existing cursor. And there are multiple ways in which you can reuse this. So for example, what if you want to reuse this cursor only during this session? So as and when the user has logged in, you want to create a cursor and you want to use the same cursor throughout their session. Once they log out, the cursor has to disappear and create a new one later on. or if you decide the same cursor has to be reused for 2 or 3 days. The scenario is in your hands. How long you want to use the cursor is up to you, and depending on that, your business logic has to be written. And it's also important to consider that you have an upper limit of 10,000 cursors per day. So imagine you have 20,000 users on your org, and all these 20,000 users are logging into the page and viewing this table of records. Now you will anyways hit the limit over there because you have an upper limit of 10,000 cursors created per day. But if 20,000 people are logging in, then you're going to hit that limit. So is the scenario that you're looking for, is cursors a right fit for that scenario, is something that you have to go back and consider. So like I said, this is not like a one size fits all kind of a scenario where this is going to be the solution for every problem that you're having. First of all, you need to figure out why do you need to show such large data sets to your users, because now you're traversing through, let's say, 10 million records. Is there a valid scenario for a user traversing through 10 million records? And how many users are going to do that? Is every single user in your org going to do that? Yes, no. So you have a bunch of considerations to take before you create a cursor and use it in UI. When you're talking about a backend automation, like a scheduled job or something that runs every night, then you're okay because you'll end up creating 1 or 2 cursors and you will reuse that through the job, which maybe runs daily or hourly, weekly. You'll still be under the limits. But whenever you're saying an end user is going to access these cursors every day, that's when you have to keep a few considerations in mind. Now, keeping all those considerations in mind, I have two options here. So first, along with returning a list of leads, I can also return the cursor ID back to the front end. And each time I paginate, I send that cursor ID back. Now that is one way of doing it. Now I have chosen to go with the way of using platform cache. So what I want to do here really is use platform cache. I have a little bit of code saved for that. Let me copy paste that so that it saves time. But essentially, I am still writing the same query, but the only change here is that the first time I'm creating the cursor, I'm putting this cursor into the session cache. I'm using the session cache and the platform cache feature. I'm putting the cursor over there. And if the session cache contains the lead cursor, I'm fetching that. If not, I'm creating a new cursor. So that's a simple if-else logic that I have. And this works out pretty well because the maximum lifespan of a session cache is until a user logs out or 48 hours, both of which is less than the lifetime of a cursor. So even though the cache expires, I'm okay, I'll be able to get a new cursor and show it. So this is something that you can do. So let me save this and deploy source to org. And now what I can do is I can call this method. So query cursor dot get leads. I'll select that and say execute anonymous with currently selected text. And what you can see here is the cursor has been inserted into the cache and the records are being fetched. Of course, I'm not showing you the records itself, but yeah, the records are going to come back. Now let's say I execute the same get leads method again. Then this time, what happened to my logs? Let me clear this and run it again. Okay, so now you can see that it is getting from the cache. So which means subsequent transactions is leveraging the same cursor and not creating new cursors altogether. So that's in a nutshell how you can use a cursor in order to overcome the offset limit. But like I said, keep in mind the number of cursors that you can create per day and work according to that. Now coming to the next example that I have. So let's take a Queueable Apex class. Now typically the use case here that I have is I have a bunch of leads and I want to process these leads in batches. And this batch size has to be configured. So maybe the first batch only takes in 20 leads. The second batch takes in 40 leads, and so on and so forth. So how do I do that? Now for that, basically what I have is a simple queueable cursor, queueable class that implements queueable. I have three private properties, one that stores the cursor, the other one that stores the current position, and the third one that stores the number of records. Now the important thing to note here is whenever you're talking about a cursor, we can only store the cursor ID. I mean, the cursor is just a bunch of records. What is the current position, what are the number of records that have been retrieved is something that you have to control. So we don't store the last position from which the records have been retrieved. So that's something that we don't store. So that's in your control. Where do you want to store and fetch that from? So what we are doing here is we are creating three private properties: locator, position, number of records. And in the constructor, so the first time the queueable method is called, like the first time it is scheduled, the constructor is called, obviously. So we are creating a cursor. So this cursor is returning the list of leads, and I'm initializing the position to 0 and number of records to 10. So that's what is happening in my constructor. Now each time my execute method is called, I'm going to do a bunch of sanity checks. First of all, I'm going to see what are the total number of records that are there in my result set and what is the current position that I'm at. So if there are 100 records, I'm at the 99th position, then I only have one more record to fetch. So in spite of the batch size being 100, if I only have one record to fetch, the second parameter for the fetch method has to be that one record. If I specify, let's say you have 100 records. If I say the start position is 99 and the number of records to query is 200, this is going to throw an exception because you are trying to query 200 records, but there is only one more record left from that particular position. So because you'll run into those exceptions, you will write a bunch of code to do a sanity check to check whether your batch size and the results that are left to be queried. What is the difference between those? If the number of results left to be queried is more than your batch size, then you can query all of your batch size. Or you will query the maximum number of records that is left in the pool. So that's all this logic, even though it might sound complicated. I'm sure this is not something that is very new. You would have done it in some of the other project. Now I'm returning the list of records. I want to do whatever I can do, whatever processing that I want. Now, in this case, I'm just logging, creating new objects. I'm creating new records for seeing how many records have been processed. This is a very demo kind of a scenario. Ideally, this can be any business logic that you have. Here, I'm inserting a few records into the process log object. We are going to see what that is. And finally, what I'm doing is I'm updating the position. So based on the number of records, what is the position, what is the next position going to be for the subsequent job? So that's something that I'm doing here. And how many records that I want to fetch. Now, you can keep this static. So each time if you want your batch size to be the same, the number of records to query can remain the same. But what I'm trying to do here is just for the demo purposes, I'm generating a random number so that I can see the total number of records retrieved each time is going to be random. So that's something that I'm doing here. And finally, I'm going to queue the job again. So this is what we call chaining of a queuable job. So within the execute method of a queuable job, I am queuing a different job, which in fact is the same job because we have mentioned this. So what I'm doing here is system.enqueueJob. This takes in all the current private properties into consideration and queues the same job again. So let's say the first time this job is running, the execute method runs with the values 0 and 10. Now within the execute method, I'm updating those values and then I'm calling the same job again. So because it's the same properties that are going to be reused over here because it is passed by reference, the same job is going to get queued with a different position and different number of records, which of course is going to be random or it can be static based on whatever you want. So this way, what you're doing is you're getting a huge set of results and you're processing how many results you want in this job. And all the remaining results, you're actually scheduling another job, another child job to process the remaining results. So that's how you can use the whole cursors concept. in order to process a large set of records. Now, let's see how you can execute this. So what I'm doing here is essentially I'm queuing the job for the first time. So system.enqueueJob, new queuable cursor. Because I have not passed any parameters, it's going to be initialized to 0 and whatever is the value here, 0 and 10. Now, if you know, there is a limit of, there is a default limit for the stack depth. That means the number of chained jobs that you can have, and that limit is 5. So depending on how many records that your job might have, so imagine this job won't be completed within 5 batches. So I'm going to set the queuable depth to 50, and then I'm going to enqueue this job. So let me see what happens. So once you enqueue this job, I have these logs that will show up. Um, so the enqueued job takes some time, so we will wait for the jobs to start. But essentially, in the meanwhile, I will take a few questions. But I'm hoping whatever I've shown you is clear in terms of both the scenarios. One is pagination, and the other one is breaking up your um, result set into different queuable jobs. All right. A few people complained that the screen is stuck in between. If you refresh, it should have gone away. So we have a limit for get cursor per day is 100 million. So I use multiple times with the same cursor ID. Will that count against 100 million limits? So the first time you create the cursor, that is when we calculate the limit of number of records that the cursor points towards. And that is 50 million, I guess, and 100 million per day. So that counts. Every time you do a fetch, that doesn't count towards that 100 million. The fetch call is something that counts towards the number of fetch calls you can make in a given transaction. So fetch counts towards that. Is there a record lock with cursor creation fetch, or records could be deleted between cursor creation and fetch calls? That's a wonderful question, Eric. In fact, I had tried it yesterday. So let's say for the ease, let's say there are 100 records in the lead object. I query for those 100 records using the cursor. And I do cursor.fetch 0, 5. And I get 5 records. Now, because I can reuse this in multiple transactions, after retrieving these 5 records, so let's say I delete one of those 5 records. Now, when I do, after deleting one of those 5 records, when I run the same fetch query again, so if I do fetch of 0, 5, then you're only going to get back 4 records because one of those records is deleted. So that's how it works. There is no lock scenario that comes in, but if a record is updated, you're going to get the updated values back. But if a record is deleted, you're not going to see that record. So if you query 5 records, you're going to get the most up-to-date information about those 5 records. If the record itself is deleted, then you're only going to get 4 from the batch that you're requesting. So imagine it this way. Imagine when you create a cursor, I don't know how it works internally, to be very frank, but the way I imagine is, let's say you query 100 records, we store all those 100 records in a table, record IDs, and then when you ask for 0 to 5, I look at what those record IDs are, return it back to you. If I delete a record, then that list is going to be empty. So that slot is going to be empty. So I'm only going to get 4 records back. So that's how I'm assuming it works. I'm sure internal implementation is quite different, but for the ease of explanation, that's how it is. Can we use it? Okay, Shantanu, let me read your question. Can we use it fetch related records and dynamic queries and social queries? I haven't tried it with social. And a cursor is created for a query at a given point in time. So if you remember the syntax, it is a query that is written in a string format. So it could be a dynamic query, but then once the cursor is executed, that's the result set that the cursor is going to contain, in spite of your query being dynamic. So Megesh asks, I think cursors fetch records only once and store it for 2 days. I wouldn't say it fetches any records. It creates like a pointer to those records that you will eventually fetch if you want. So Harikiran, what happens if the data gets deleted in the backend? Yes, that's what I was talking about. If it gets deleted, that slot is removed, and then you continue parsing the same set of results. Does cursor ID stored anywhere in Salesforce? So cursor ID is not stored anywhere per se. I mean, we return the cursor ID back to you when you initialize a cursor. It is up to you to store it and reuse it again. Is there any way to find out if the cursor expired or not? Look for an exception. If an exception is thrown, then your cursor has expired. Then there is a final question. Will cursor store the same data? Each time the data changed in the database, will it be updated automatically? In terms of the number of records the cursor points to, it may or may not be updated. I did not test that, but the data itself is updated. So let's say you have created a cursor now for a lead, and tomorrow the name of the lead changes, or you update the name of the lead. When you use the fetch call again, you are going to get the updated name back. And in fact, today morning when I was checking for a previous cursor, actually when a cursor is created, it is created for those number of records that were retrieved at that point in time. So if you add new records in the future, you need to create a new cursor. So that's a different consideration. So cursors versus the dynamism of the data that you have. If the data is updated frequently, like the count of records, then you might end up creating multiple cursors. Yes, Shantanu, that is correct. So whenever we are talking about record updates, whenever you write a fetch statement, the records that are shown to you will be the most up-to-date records. But the count of the records will be the same as it was when the cursor was initially fired. So let's say today I'm creating a cursor, it's returned only 100 records, but tomorrow morning some 2000 leads have been inserted. If I use the cursor that I created today, it will still show me only those 100 records. I need to create a new cursor to get those 2000 records back. So think of cursor to be a snapshot of data of that particular point in time. So yeah, that is pretty much the questions that I can take in the time that we have. So let me refresh. I think the job is being scheduled in the backend. We will figure it out on what the problem is. Did it throw any exception? Not really. So yeah, I think the job is taking time in the queue. But what it would essentially show is different sets of records being processed um, with various batch size because it is being generated at random. So yes, that is pretty much what I wanted to show you today about Apex cursors. I want all of you to try it out. Since this is in beta, we are definitely looking for feedback, and any scenarios that you come up with, you can let us know. And before making it GA, if you are able to address some of your requirements, we will definitely try and do that. So please try it out. Let us know how it feels. You can drop in a note to either me or the product manager. So Daniel Ballinger is the product manager for this particular feature and Apex in general. So if you're already connected with him, drop him a note on anything that you think is not working as expected. So that's pretty much what I have in today's codeLive. Hope this was a good use of your time. And I definitely hope I'm going to see you soon in a different codeLive in the near future. So with that, thank you all of you for your time and see you all soon. Bye-bye.